Hi, in this video I am going to discuss 6 or 7 questions on projectile motion related to mathematics, mechanics into Edexcel IAL syllabus. Okay, so this is the first question. You can note down or you can read the question first, then I'll discuss that question. A particle is projected from point O on a horizontal plane and the particle moves in a two-dimensional plane. Okay, it's vertical plane, it moves on a two-dimensional plane. During its motion, it passes through a point P which is at a vertical height of B and at a horizontal distance of A from O. So, okay, we'll think about that. This is the projectile. So, we draw the diagram, just sketch the diagram. Okay, so this is the point O. It was projected from O, but initial speed is not given. I'll just take the initial speed U at an angle alpha. I'll take it. During its motion, it passes through a point P. We don't know the point P is on the left side of the highest point, the maximum height, or right side of the maximum height. We don't know. We'll just take a point P just somewhere here. This is the point P. Which has a height of, which is at a horizontal distance of A from O. So the horizontal distance of it from here, if I draw a vertical line, so this horizontal distance is A. This horizontal distance is A, and the height is B. The height of the point above that, above the initial point O, that is B. So this height is B. This is B. So this is the point P. Okay, for the same initial speed, not given, I just took it U. For the same initial speed, if the particle could be projected at two different angles, alpha 1 and alpha 2, such that it passes through this point P. So if I draw the diagram again, normally we draw like this, but if a particle wants to move through a point P, we could project it at two different angles. So if I draw it again on the same diagram, or again I can draw something like this. The first projectile could be like this. Okay, second thing, we could project at another angle, something like this, such that it passes like this. But the range could be different. The range could be different. So this is a second projectile. So if I say the initial angle alpha 1, which I drew earlier, if I take that initial one as alpha 1, and the second one, which is drawn by using black ink, the second projectile, that initial angle is alpha 2. The angle of projection is alpha 2. Both are passing through the same point P, but they have different ranges. The ranges will be different, but both have the same initial speed. That's what the question says. For the same initial speed U. So the first projectile, which is projected at alpha 1 at speed U. The second projectile projected at angle alpha 2, the same speed P, U. Both are passing through, both could pass through point P, but they could have different ranges. Then we should show the distance of the point P, horizontal distance A, vertical height P. So we should show that tan alpha 1 plus alpha 2, where alpha 1 is the angle of projectile motion, or the angle of elevation of the first projectile alpha 1, angle of elevation of the second projectile alpha 2. Tan alpha 1 plus alpha 2 is equal to minus A over B. We had to derive it. Okay, so we'll do that. We'll start like this. You can see the question again. I'll give you just 30 seconds. Okay, so that's nothing we'll do normally, just generally we'll do it. We know that horizontal distance A, so the initial, if I use horizontal, is equal ut plus half at squared. A is equal to u cos alpha times t, and horizontally no acceleration, you know that. Okay, so I can find the time in terms of A and alpha, so t equal A over u cos alpha. U is unknown. I just put 2, we'll see. Later we might eliminate it. Right, that's the time taken for this motion. The height is p, so we can use vertically s equal ut plus half at squared for the motion from O to p. If I use vertically, s equal ut plus half at squared for the motion from O to p. So s is b u sine alpha into the time is a over u cos alpha plus half minus g, because I am using upward direction, so the acceleration is gravitational acceleration g t squared. So instead of t squared I can substitute a squared over u squared cos squared alpha. Okay, so here you will get cancel sin alpha, cos alpha, tan alpha. So b is going to be, b is equal to a tan alpha minus a squared g minus a squared g over 2u squared sec squared alpha. You know 1 over cos squared alpha, 1 over cos is sec, 1 over cos squared alpha, sec squared alpha. So sec squared alpha. You know sec squared theta equal 1 plus tan squared theta. You know that sec squared alpha equal 1 plus tan squared alpha. So we replace like that. B is equal to a tan alpha minus a squared g over 2u squared 1 plus tan squared alpha. Okay, so the purpose why am I doing like this means I am going to get a quadratic equation in terms of tan alpha. Like normally we come across quadratic equation in terms of ax squared plus bx plus c format. Like that, here I am going to get a quadratic equation in terms of tan squared alpha. So if there are two angles of projectile, or if there are two angle of elevation initially, alpha 1, alpha 2, the root of this quadratic equation will be tan alpha 1 and tan alpha 2. So that's what I'm going to take now. Right, okay, we'll see. So we'll solve it further. I can multiply the whole equation by 2u squared. So it's going to be 2bu squared, cross multiply 2bu squared equal to 2a u squared tan alpha minus a squared g minus a squared g tan squared alpha. Okay, we'll arrange it, rearrange it in proper quadratic equation format. So it's going to be a squared g tan squared alpha, I'll bring it to left, minus 2a u squared tan alpha plus 2bu squared plus a squared g equal to 0. Carefully we have to solve it without making any mistake. Okay, so if the solutions for this quadratic equation, it's a quadratic equation in terms of tan squared alpha, tan alpha. So it's a quadratic equation in tan alpha. If I imagine tan alpha as x, ax squared minus 2au squared x plus this constant, because b, u, they are all constant for a given speed. So u is a constant, a and b are given height and distance from O, so they are constant. So it's a quadratic equation in tan alpha. So the roots of these will be, if the angle of projectile, the angle of elevations are alpha 1 and alpha 2, the root of these quadratic equation will be tan alpha 1 and tan alpha 2. You know that in quadratic ax squared plus bx plus c equals 0. If the roots are alpha 1 and alpha 2, if the roots of this equation is alpha 1 and alpha 2, then alpha 1 plus alpha 2 minus b over a, alpha 1 times alpha 2 c over a. You know that. I'm going to use the same thing here again. So if there are two angles alpha 1 and alpha 2, the roots are tan alpha 1 and tan alpha 2. So the sum of the roots is it tan alpha 1 plus tan alpha 2, alpha plus beta, normal quadratic equation. So tan alpha 1 plus tan alpha 2 minus b over a, minus 2a u squared minus b over a, that is a squared g So if you solve it, minus and minus plus 2u squared over ag. Take it first equation, first solution of first equation. It's okay. Then multiplication of alpha 1 into alpha 2. Normally we say, sorry, alpha into beta, C over A, alpha into beta, general equation. So here tan alpha 1 into tan alpha 2, the roots are tan alpha 1 and tan alpha 2 are the roots. So tan alpha 1 into tan alpha 2 is equal to C over A. C over A means here C is this one. So that is 2bu squared plus A squared G over A means A squared G. Okay, we need to solve. I'll erase the left side. Okay, we'll continue this. A squared G, so 2bu squared over A squared G plus A squared G over A squared G, that will be 1. So tan alpha 1 into tan alpha 2 equal 2bu squared over A squared G plus 1. Okay, right? The question is about tan alpha 1 plus alpha 2. Tan alpha 1 plus alpha 2, we know that tan alpha 1 plus alpha 2 equal tan alpha 1 plus tan alpha 2 over 1 minus tan alpha 1 into tan alpha 1 into tan alpha 2. Okay, now we'll substitute here. Tan alpha 1 plus tan alpha 2, we have it. 2u squared over ag. 2u squared over ag over 1 minus tan alpha 1 into tan alpha 2, we got it. 1 minus 2bu squared over a squared g plus 1. Okay, solve it, you will get the answer. So here minus 1, that will get cancelled. Here minus there. So we'll rearrange it. I'll erase that side. Okay, so if I continue, tan alpha 1 plus tan alpha 1 plus alpha 2. 2u squared ag, 2u squared over ag into 2bu squared over, these get cancelled, minus 1, 2bu squared over a squared g. Here minus sign, so that minus we'll put it here. Okay, solve it here. Is ag, a squared g, g get cancelled. A, here a will be there, a will remain here. So here u squared will get cancelled. 2 will get cancelled. So finally we'll get minus a over b. That's the answer. That's the question they asked. That's the answer. Okay, so this is the second question. A particle is projected from point P on a smooth horizontal ground at a speed of square root of k a g, where k is a constant, and at an angle of elevation of alpha. So what is a? They are coming later. Angle of elevation alpha. During its motion, it just passes over two identical vertical parallel walls of height a. So this a and this a are the same. Okay, the height is a. In the speed also a is given, doesn't matter, but k is a constant, right? And the horizontal distance between the two walls, 2a. So the distance of the first wall, so if we draw a diagram, we know that both walls have the same height, means they should be on either side of the highest point, because it's symmetrical, is it? The projectile motion is symmetrical. So if I sketch a diagram, so for the projectile motion, it looks like that. Okay, so if it is projected at an initial speed u, not given, angle alpha for a given angle. So this is the highest point if I take it. So the two walls, if this is the first wall which has height A, the second wall should be on the other side of the highest point, because the projectile path, the trajectory is symmetrical. So the second wall should be somewhere here, that also have the same height A. The distance between the two walls is given as 2A. And the first wall is at a distance of D, capital D. Anyway, we know that if this is a physics question, without doing any further calculation, we know that from the second wall to the point where it hits the ground, that also must be equal to D, because it's a symmetrical shape. So A and A are on either side of the highest point. The first wall is from D, means the end point from the second wall also must be D. Without doing calculation in physics, we can explain by using the symmetrical path of the trajectory about the highest point. Okay, so this is also capital D. We can use it, but here mathematically also we can show that. But in physics, we don't use much mathematics, so there we can use the idea of symmetrical shape of the path. It's a parabolic path about the highest point on the left side, and the right side is symmetry. So if this is D, this must be D. Anyway, but that's not a question. Okay, so the first part we have to show this. Second part, this one. Okay, so there's nothing much. We have to use the normal equation. We'll use the equation of motion to find the highest point. Find the height of a particular wall. And the horizontally we use S equal ut plus half at squared. Then beyond it, maths. Either we might use quadratic equations, alpha plus beta minus b over a, alpha beta c over a, we'll use it. Or maybe a little bit of trigonometry, or maybe algebra. Say for example, we know that these are the techniques we use. That so we know that x plus y all things squared is equal to x squared plus 2xy plus y squared. X minus y all things squared equal x squared minus 2xy plus y squared. If you know how to relate x plus y square and x minus y square, we can write that x minus y all things squared is equal to, we know that x squared minus 2xy plus y squared. So x minus y all things squared is equal to x plus y all things squared. So there we will get x squared the same, y squared the same, but here minus 2x we are going to get plus 2xy. So minus 4xy. So I'm going to use that technique here, nothing else. Okay. So those are the techniques, basic, even IGCSE mathematics we use here. Looks scary, the question, but it's nothing actually. Okay, we'll continue that. I just sketched and explained about the technique I'm going to use here. Okay, so here I'm going to use S equal ut plus half at square vertically upward, because the height is given as A. What could be the equation for the vertical height A? So I'm sure that there will be two different time to have the same vertical displacement. Is it? There will be two different time to have the same vertical displacement A. Okay, so we'll use vertically upwards. S equal ut plus half at squared. So A equal u sine alpha. I'll substitute the u, given that u is the square root of k something, k a b or k a g. I'll substitute that later. I'll just use it as u, easy to handle, into t plus half minus gt squared. Okay, so if I solve this, you'll get it's going to be so we'll rearrange it. Multiply by 2, 2a equal 2u sine alpha times t minus gt squared. So it's a quadratic equation in t. I'll rearrange this equation. Gt squared minus 2u sine alpha t, correct, no? So gt squared minus 2u sine alpha into t plus 2a equal to 0. Yeah, so it's a quadratic equation in time. So there will be two real solutions. There must be two real solutions for time because it has two different time to have the same height A, to have the same height A, same vertical height A, to have the same vertical height A. There will be two different times. So let them be T1 and T2. T1 is the time taken to reach the first wall, T2 is the time taken to reach the second wall. We'll take it like this. Okay, so the two solutions are T1 and T2 are the solution or are the roots of this quadratic equation. Right, okay, so we know that T1 plus T2 alpha plus beta equal minus B over A. So T1 plus T2 equal minus, this is like a B. So minus into minus plus, you will get 2U sine alpha over A. A is G. This is the first equation. You take it as the first equation. T1 into T2, T1 into T2, that is equal to C over A. That is 2A over G. Right. We got two relations between T1 and T2. Now we use horizontal because there are two different horizontal distance. For the first wall it is D. For the second wall it will be D plus 2A. So we'll try with this T1 and T2. I told I take T1 as the time taken to reach the first wall. Means if I use horizontally, S equal UT plus half AT squared. Because I need to get some relationship between T1 and T2 and find the values of T1, T2 to find the D. So we don't know. I don't have the value for T1 or T2. So I'm going to find it. So for that I need more equations. So I'm using horizontally S equal UT plus half AT squared. So the first wall, the distance is D. For the first wall, D is equal to U cos alpha. I'll substitute the U later. U cos alpha into T1. Okay, so let it be equation 3. For the second wall, if I use D plus 2A is equal to U cos alpha times T2. That let it be equation 4. Okay, we'll subtract this one. Equation 4 minus equation 3. D plus 2A minus D, that is going to be 2A, is equal to equation 4 minus 3, because I want to get some relationship between T2 and T1 again. So 2A, that is 4 minus 3, that is D plus 2A minus D, that is 2A is equal to U cos alpha T2 minus T1. So T2 minus T1 is equal to 2A over U cos alpha. Already I know that T1 plus T2 I know that T2 plus T1 that is equal to, or T1 plus T2, 2U sine alpha over G. From these two we will find T1 and T2. Then substitute here. You will get the first answer. Okay, we will continue. So I need to find the T1. So I'll subtract this minus this. So that is, if I subtract from here minus this, T1 minus T1, so T2 will get cancelled. So I'll raise the left side, this one. Okay, so this equation minus this equation. I didn't put the numbers. If you want, I can put the numbers here. This equation 5 and 6. So 6 minus 5. 6 minus 5 means T1, T2 will get cancelled. T1 minus T1, that's going to be 2T1. 2T1 is equal to 2U sine alpha G, 2U sine alpha over G minus 2A over U cos alpha. So divide by 2, you will get T1 is equal to U sine alpha over G minus A over U cos alpha. Okay, that's a T1. Okay, we know that D is equal to this one. Substitute there, you will get the answer and replace and substitute U is equal to square root of kAg, right? Okay, so from the equation 3, d is equal to u cos alpha times u sin alpha over g minus a over u cos alpha. Okay, continue that. So you will get u squared, u into u squared, sin alpha cos alpha over g minus cos alpha will get cancelled, u will get cancelled, minus a. Okay, I'll raise that and continue there. Okay, so already it was there. I'll continue with the black ink. So that means d is going to be, d is equal to, instead of u, we'll substitute, u is given as kAg, so u squared equal, u is given as square root of kAg, u squared is going to be kAg, so kAg sin alpha cos alpha over g, so g and g is going to get cancelled, minus a, so it's going to be Ka sin alpha cos alpha minus a. The answer was, yeah, a take common, a is going to be, so d is going to be, take the a out, k sin alpha cos alpha minus 1. That's the question they asked to show. Yeah, we got the answer. Okay, the second part, they asked to show that, I already wrote the question, they asked to show that, second part, they asked to show that, I'll write the question, sec to the power 4 alpha minus k squared minus 2k sec squared alpha plus k squared equals 0. That means that shows that we have to eliminate the distances, we have to eliminate the a, we have to get relationship only among the angles, sec alpha format. Okay, so what to do that? We'll use these equations that t1 plus t2 we know that, t1 t2 we know that, so we'll find t1 minus t2 minus t1, because we know t2 is the time taken to reach the second wall, means we'll try to find the t2 also. We know the t1, we got the t1 here, this one, substitute here and find the t2. Then we will have two equations. We know t1 plus t2, we can find t2 minus t1. Then we'll continue with what I told, that t1 minus t2 all things squared equal to t1 plus t2 all things squared minus 4 t1 t2. Substitute, you will get the second part. So we can eliminate everything from there, the unwanted things. Okay, so we know that t1 is equal to u sin alpha g minus a over u cos alpha. Substitute in first one and find the t2. Okay, so that means t2 is going to be t2 equal to u sin alpha over g minus t1 means minus u sin alpha over g minus a over u cos alpha. Okay, sorry, that's going to be 2u sin alpha g minus u sin alpha g, means that is u sin alpha over g minus into minus plus a over u cos alpha, that is t2. Okay, so second part, I told that there's nothing else to do. We have used all the relationships related to all the theory or all the information related to projectile motion, we have used it. So the only thing remaining is something we had to eliminate and get the second relationship. We had to get relationship only in terms of alpha and k, sec alpha and k. So there's nothing to think more related to projectile. We have used all the concepts related to projectile motion. Now remaining is only mathematics, algebra, right? Okay. So we'll know the t2. So we'll try to find t2 minus t1. So t2 minus t1 is going to be t2 I know that, t1 I know that, t2 minus t1. So this minus this, So that's going to be u sin alpha or g, u sin alpha or g will get cancelled. So t2 minus t is 1, that is a over u cos alpha minus, so plus a over u cos alpha, that's going to be 2a over u cos alpha. So we need 1, 2, and I put this as equation 7, I think, doesn't matter whatever the number. So I'm going to use only these 3 equations for the second part. I'll continue now. There's nothing related to projectile or concepts or theory related to projectile. We have used everything now so far. So only thing remaining part is algebra. We had to find out, we had to get some relationship, elimination. We had to eliminate other unknowns and get only the relationship among sec alpha, right? Automatically that answer will come. Okay, so all these 3 we got it in the first part. I'm going to use them to get the second part. Okay, so we know that t2 minus t1 all things squared is t2 squared minus 2 t1 t2 plus t1 squared. And we know that t1 plus t2 all things squared, I already explained that when I start, t1 plus t2 all things squared is equal to t1 squared, same as here, t1 squared, t2 squared, that also here, but here minus 2 t1 t2 comes, here plus 2 t1 t2 comes. If I want to relate this, minus 4 t1 t2. If you want, you can write other way also, t2 plus t1 all things squared equal t2 minus t1 all things squared, here plus 4 t1 t2. You will get the same answer, nothing will go wrong. Okay, you try, you will get the same answer. So you don't ask me why I started with t2 minus t1, not t2 plus t1. Yes, you can do that, but only thing, if you write here t2 plus t1 all things squared, here t1, here you will get t2 minus t1 all things squared plus 4 t1 t2 bracket. Nothing will go wrong, right? Okay. So t2 minus t1, I know that is 2a over u cos alpha all things squared equal to t1 plus t2 2u sin alpha over g all things squared minus 4 t1 t2 4 8 is it 4 into 2 8 8a over g, right? We'll expand it, it will become 4a squared over u squared. Here there will be cos squared alpha, 4a squared or u squared cos squared alpha, that is 1 over cos squared alpha, is it? It's a denominator cos squared alpha, so that is 1 over cos squared alpha means sec squared alpha. I can write this as sec squared alpha. This here 2u squared over g sin squared alpha. Sin squared alpha equal to 1 minus cos squared alpha. Here 4u squared, sorry. Here 4u squared over g squared, 4u squared over g squared, sin squared alpha equal 1 minus cos squared alpha. I can write it, but too much of steps, so to reduce it, I wrote everything. 2 into squared, 4u squared over g squared, sin squared alpha, 1 minus cos squared alpha, minus 8a over g. Okay, so cos squared alpha, you know that 1 minus cos squared alpha, this 1 minus cos squared alpha, I can say that as a 1 minus 1 over sec squared alpha. Is it? I can write that. Right, okay, so I'll continue that way. So I can expand inside, so it's going to be 4a squared over u squared sec squared alpha equal to 4u squared over g squared, 4u squared over g squared multiplied by 1, so 4u squared over g squared. Here 4u squared cos squared alpha comes 4u squared cos squared alpha over g squared. This cos squared alpha I can write 1 over cos squared. This is, I can write this as, I can write 1 over cos squared alpha, is it? This will go up. So this 1 over cos squared alpha, sec squared alpha. I'll put it as g squared sec squared alpha minus 8a over g. Check it. Okay, so next. So we'll substitute u equals square root of, given as u equals square root of g given. So we'll substitute that everywhere because the a, those things will get cancelled. So I'll substitute now. It's going to be 4a squared z squared alpha over k ag. So now here a going to get cancelled. We'll see that equal to 4 times k ag over g squared minus 4 k ag over g squared sec squared alpha minus 8a over g. I'll raise the upper part. Okay, so I will solve it step by step. So that will be easy if I use this equation. So I'm going to cut and raise to solve it. So now you know that here a squared, here a. So a will get cancelled. So this a I am raising it. So it will become a. Here g squared. So this g and this g will get cancelled. Same way here g squared. So that g will get cancelled. Right. When you consider the whole equation, a will get cancelled. So all a are going to get cancelled. I think it's easy to explain, like you would have written it. Okay. Now g, all the g will get cancelled. So that also has no denominator. So this g will get cancelled. Now when you consider the numbers, here 4, 4, 4, so 8 means I can divide whole thing by this will become sec squared, here k, this will become 2, okay. This will become 2, yes. Okay, now we will multiply the whole equation by sec squared alpha and we will multiply the whole equation by sec squared alpha and again k. So it will become sec to the power 4 alpha. It's there, no, in the answer. Yeah, multiply by sec squared alpha. If you multiply by sec squared alpha, you will get sec to the power 4 sec to the power 4 alpha over k equal k sec squared alpha minus k minus 2 sec squared alpha. Again multiply by k, the whole equation. So that will become sec to the power 4 alpha equal k squared sec squared alpha minus k squared minus 2k sec squared alpha. I think I am right. Yeah. Okay. So rearrange it. Sec to the power 4 alpha. So we'll bring everything to the left. So sec to the power 4 alpha minus k squared sec squared alpha. Here 2k squared sec squared alpha. So it's going to be minus k squared sec squared alpha. It will become plus. Is it when I bring it to the left side? Sec to the power 4 alpha k squared sec squared alpha. And here it's going to be I think k squared sec squared alpha. It will become minus k squared sec squared alpha plus 2k sec squared alpha plus k squared equal to 0. Okay, now that's all, but the only thing we need to rearrange it according to the question. So sec to the power 4 alpha minus, the question says minus k squared minus 2k, yeah, k squared minus 2k, yeah, minus k squared minus this 2k sec square alpha. So minus I took it out. So minus k squared 2k sec squared alpha plus k squared. Yes. Equal 0. That's the question. We got it. Looks scary, but be confident and answer it. Okay, so this is the third question. It says two particles P and Q are projected simultaneously from the same point O with the same speed, but at different angles of elevation. Angles of elevation of P and Q are alpha and 90 minus alpha. That means if alpha is 30, the next one is 60, 90 minus 30. Or first one is 40, the second one will be 90 minus 40, 50 degree, like that. Alpha and 90 minus alpha respectively. Show that both P and Q will have the same range. That's the first part we need to show. That's nothing hard. Second part, show that when both are in motion. So when both are in motion, the line that joins P and Q. So you can connect the particles P and Q, a virtual line or imaginary line. If you connect P and Q by a line during their motion, that will always make at any time t that will make an angle of 45 degree with horizontal. We have to show that as the second part. Okay, so both particles are projected from point O, it says, I think, yeah, from point O. So this initial point O. This is the blue color path indicates for the particle P, the black color for particle Q. The angle of elevation of P is alpha, for angle of elevation of Q is 90 minus alpha. So I took 90 minus alpha is greater than alpha. Doesn't matter, anyway I can take either way. I drew it like both have the same range, but I want to show that if I want I can, yeah, I can remove this part. We don't know whether they are going to have the same range, but we'll see. I'm going to show that they have the range same, right? Okay, so for particle P, if I write, you know, normally I'm going to get an equation for the range R equal to 2u squared over g sine alpha cos alpha. Anyway, I'll show that for the whole motion, if I consider vertically, s equal ut plus half at squared. So that will be 0 when it hits the ground. Yeah, when we consider the range, means it come back to the same horizontal level. That vertical displacement will become 0. S equals 0 for the complete motion. I am considering for P, I consider complete motion. So S equal that initial spin u sine alpha t minus half g t squared. So it's going to be 0 equal u sine alpha minus half gt. So from this t equal 2u sine alpha over g. When I consider horizontally, s equal ut plus half at squared for p, the range of p r is going to be r equal u cos alpha into time 2u sine alpha over g. So it's going to be u squared over g into 2 sine alpha cos alpha. You know 2 sine alpha cos alpha equals sine 2 alpha, you know that. So it's going to be u squared over g sine 2 alpha. That is the range of P. Okay, so the particle Q that also projected, that is Q is black color path. That angle of elevation is 90 minus alpha for Q. That's the way the question says. Yeah, no, the P and Q are alpha and 90 minus alpha. Okay, then if I consider this is for P. For Q, if I consider, I don't need to do the same thing again. The only difference is, instead of alpha, I should substitute 90 minus alpha. That's the only change, is it? Initial speed is the same, they are saying. So if I take that range, its range is R1 is equal to u squared over g sine, instead of this 2, 90 minus alpha. That's going to be u squared over g sine 180 minus 2 alpha. But you know that in the trigonometry, the second quarter, this is all positive. This is second quarter. 180 minus alpha for sine is sine alpha. Sine 180 minus theta is sine theta. You know that sine 180 minus theta is equal to sine theta. So this one is going to u squared over g. Sine 180 minus 2 alpha means that's going to be sine 2 alpha, is it? So this I can write, same thing will come here. If I rewrite again, this is going to be, R1 is going to be u squared over g sine 180 minus 2 alpha sine 2 alpha. But u squared over g sine 2 alpha, u squared over g sine 2 alpha is R. So both will have the same range. That's what they asked to show. Both will have the same range. Okay, now second part. Okay, so during their motion, when both are in motion, both were projected at the same time, at the same speed. So when they are in motion, which one will have larger horizontal displacement at an instant? At an instant, which one of P or Q, which one will have the greatest displacement means? You know the horizontal displacement just given by S equal U cos alpha into T for P. This is for P. For Q, the horizontal displacement S2, I'll say S2 is equal to U cos 90 minus alpha into T. That is for Q. Right. On my diagram, I took the angle alpha is smaller than 90 minus alpha. That's the way I took it. There's no reason. Just I took it. Alpha is smaller than 90 minus alpha. So when the alpha becomes smaller, cos value will increase. You know that. Cos value increases when the angle becomes smaller in the first quarter. So here S1 cos alpha, this is cos 90 minus alpha. So S1 will be greater than S2 at the same time t. When you consider a particular time t, particle P will have greater horizontal displacement than Q during their motion. So if I consider the positions during their motion, if P is here, somewhere here, Q will be somewhere here. Q will have smaller horizontal displacement at any time t, because according to my diagram, I took the angle alpha smaller than 90 minus alpha. So when the alpha becomes smaller, cos value will increase, so it will have larger range. We need to show the line that connects P and Q makes an angle 45 degree with horizontal. So this line, we have to imagine this line. Sorry. Okay, this is the line which connects. It's a virtual line or imaginary line. That line makes an angle 45 degree horizontal line. So we'll take at an instant the horizontal displacement of Px1 and its vertical displacement y1. So I'll take its coordinates x1, y1. This as x2, y2 at time t, at particular time t. Horizontal displacement of P is x1 and its vertical displacement y1 for q, x2, y2. Right. So I need to show this line, the red color line. PQ makes an angle horizontal with horizontal 45 degree. Okay, we'll consider just tan theta like a gradient. We'll imagine about y2 minus like this angle, that is y2 minus y1 over x1 minus x2. Is it? That is tan theta. How much could it be? So nothing else. That I had to find it, tan theta. Okay, now I'll make that angle with horizontal line. This one I'll make with horizontal beta or theta, whatever it is. This line with horizontal line. This angle, I'll make it as theta. So I need to show the theta, right? Okay, so for that, we'll consider the horizontal for P. We'll consider horizontally S equal ut plus half at squared. That is x1 equal u cos alpha plus 0. No acceleration horizontally. Say x1 equal u cos alpha into t at a time t. Vertically, if I consider y1 equal u sine alpha times t minus half g t squared. Okay, this is for P. For Q, if I write it horizontally, x2 is equal to the same equation, s equal ut plus half at squared, I am going to write. So x2 equal u cos 90 minus alpha into t, because we are considering at the same time, at a particular instant, the line makes 45 degree, we have to show. So the same time t here, cos 90 minus alpha sine alpha. So x2 is going to be u sine alpha times t. Same way, vertically, displacement y2 equals, same equation I am using, s equal ut plus half at square, u sine 90 minus alpha t minus half gt squared. So it's going to be u sine 90 minus alpha cos alpha, u cos alpha times t minus half gt squared. So that is y2. So we have x1 y1 we have, same way x2 y2 we have. Okay, so if I consider the line makes an angle theta with horizontal, I need to find the tan theta. Theta is the angle with horizontal for the line PQ. So tan theta is like a gradient of a line. So tan theta equal to y2, this is larger value, is it? y2 minus y1 over, this is larger, x1 minus x2. Okay, y2, that is u cos alpha into t minus half gt squared minus y1. y1 is u sine alpha minus half u sine alpha into t. u sine alpha into t minus half g t squared over x1. x1 is u cos alpha into t minus x2. Yeah, x1 minus x2. That's right. Yeah, u sine alpha into t. Okay, we'll solve it. So minus half gt squared minus into minus plus half gt squared. So half gt squared will get cancelled. U cos alpha into t minus u sine alpha into t. Take the t out. So it's going to be u cos alpha minus u sine alpha into t over here u cos alpha into t, u sine alpha into t. Same thing we are getting here. Okay, so it's going to be 1. Denominator, numerator 1. Will get cancelled. So tan b theta equal to 1. Tan theta equal to t1 means theta equal 45 degree. That's the question they asked to show. Okay, question number 4. A small ball is projected from point O on a horizontal ground at a velocity v meter per second and at an angle of elevation of alpha with the ground. The ground is horizontal anyway. During its motion, the ball just passes over a vertical wall of height b at a horizontal distance of c from O. So we don't know if the wall is after or beyond the maximum point, the highest point, or before that, we don't know. Whatever we can take, no problem. During its motion, the maximum height reached by the ball is h, means above the ground, is it? Show that this format we have to show. So nothing, we'll use this normal equations. Maximum height means we can use vertically v squared equals u squared plus 2as. The highest point where the vertical component of the velocity is 0, we'll use that. So from that, anyway, we'll solve it to get this format. Nothing, I already told that the concept related to projectile motion is the same, we are using it, but different final answer we had to get it. So when you are doing these type of question, then and there you should check the question, what should we show, what format should we show. So according to that we should take the proper path. Don't just close the eye and always write the same equation like that. You have to check here, then and there the question also, what should we get. So according to that you have to rearrange your equations, right? Okay, so at the highest point, the vertical component of the velocity is 0, means I can use v squared equal u squared plus 2as vertically from the initial point to the highest point. V squared u squared plus 2a. So v squared 0, u squared is v sine alpha all things square plus 2 minus g h. So that is v squared sine squared alpha equal to 2gh. Okay, we'll keep it like this. Sometimes we need to substitute v squared because in the answer what they asked to show that, I told you then and there, check the answer. In the answer they show that h equals c squared tan squared alpha over 4 into c tan alpha minus a. So v squared is not there. So we'll make the v squared subject. So v squared equal 2gh over sine squared alpha. Okay, for the motion from O to the initial point is O, so that is here O. O to B when we consider horizontally is equal to ut plus half at squared if we use. That is C equal u cos alpha times instead of t, okay, t plus 0. So t is going to be C over u cos alpha. When we consider the vertical motion, S equal ut plus half at squared for the motion from O to the wall. Normally we are doing the same thing. S is V, that is V sine, this is V, so not U, this is V. V sine alpha, into instead of t we can put C over V cos alpha plus half minus G t squared, that is c squared over v squared cos squared alpha. Okay, normally we convert the cos squared alpha to sec squared alpha, then 1 plus tan squared alpha. We proceed that way. Okay, if you go that way also, you will get the answer. But I told then and there, check the answer. Now you can see the answer is related to something c squared tan squared alpha. So instead of v squared, if I substitute 2gh over sine squared alpha, 2gh over sine squared alpha, the sine squared alpha will go as a numerator, then sine squared alpha over cos squared alpha give the tan squared alpha. And there is c squared. So it's going to be c squared tan squared alpha, I am getting it. That part of the answer, that is one of the part of the answer. So don't convert this to sec squared alpha. But if you convert to sec squared alpha, there also you can get the answer, but you need to go little more, you need to work out little more. But I am not converting like that because I know the answer, the final answer. We have to check then and there. I already told several times. So we will continue like this. It's going to be equal, we will get cancel c tan alpha. That is c tan alpha. You can see that. The answer. Check the answer. C tan alpha is in the numerator. I got that. Minus g c squared over instead of v squared 2gh over sine squared alpha times cos squared alpha. Okay, I know that sine squared alpha will go up, sine squared alpha cos squared alpha, I will get tan squared alpha, g and g will get cancelled. So I will get b is equal to c tan alpha minus g and g will get cancelled. There is c squared. This sine squared alpha will go to the numerator, sine squared alpha cos squared alpha tan squared alpha over g and g got cancelled 2h. Okay, now make the h subject. That's all. I'll get the answer in the next line. Okay, so rehash this one. So make this subject because I want to make the h finally subject. So it's going to be c squared tan squared alpha over 2h equal to c tan alpha minus b. Make the h subject, you will get the answer, that's all. So that is c squared tan squared alpha over 2 is missing somewhere. Okay, here I made a mistake. This half is missing, this half is missing. So that half here v squared is equal to 2gh over sine squared alpha, so it will become 4gh. 4gh. So this will become 4h. Yeah, that's a careless mistake. So v squared I, that is 2gh over sine square alpha. This half I missed it, so 4gh. So it will be, this is 4h. So h equals c squared tan squared alpha over 4 times c tan alpha minus b. Yes, that's the answer. Is it c squared tan squared alpha over 4 times c tan alpha minus b. Yes, that's the answer. We got it. But if you have taken this one as a sec squared alpha, there also you will get it right, but little more you have to work, right? So that's why you have to check the answer frequently. So this is c squared tan squared alpha. That half early I missed it, yeah. That's the answer. So we got the final answer. That is h. Okay, fifth question. A particle is projected at an angle of elevation theta from a point O, which is at a height h above the ground. So it's not from the ground, it's above the ground. Initial height is h. After time capital T, so that's going to be the flight time, the time of motion. The particle hits the ground at a horizontal distance of 2h from O. So the horizontal displacement 2h. During the collision with the ground, the particle makes the velocity makes an angle of beta with the ground. You know how to find the angle of collision during collision, but how to find the angle of velocity? We find the horizontal component of velocity, vertical component of the velocity. Tan beta is equal to vertical component over horizontal component. Say for example, if a particle is projected and if it hits the ground, whether it's from a height or whatever it is, at a point, if you want to find the angle of the velocity with the ground, find the VH component, find the vertical component. This angle is given by theta, tan theta equal, or tan beta, whatever it is, vertical component VV over VH. That's a normal whether we do that, is it? VV over VH. So we have to follow that one to find the first part. Okay, so don't think too much how should I get the answer like that. You do it normally, whatever the principle related to or the concepts related to projectile motion, and then solve it such that you get the final answer. Okay, so we'll do whatever the question here. Initially it was projected from a height h at an angle theta. Initial velocity we take it as u, and when it hits the ground, it makes an angle velocity. Makes an angle beta. We need to find the VH and VB. Okay, so we'll see what's could be the time taken. If we consider horizontally, the range is 2h given in the question. The range is 2h given in the question. So we'll use horizontally. S equal ut plus half at squared. So that is 2h equal u cos theta times t plus 0. No acceleration. So t is going to be 2h over u cos theta. Okay, that's all we can say up to now, right? Now when we consider the vertical displacement, that's given as h, so we use it. So vertically when we consider the motion is equal ut plus half at square. If I consider downward direction, that is h equal initial velocity vertically upward, so minus u sine theta. Minus comes because the initial velocity is upward, I am taking downward positive. Instead of t, substitute this one, 2h over u cos theta plus half minus g, same thing we are using, t squared, 4h squared over 4h squared, is it 4h squared over u squared cos squared theta. Don't convert to sec square unwantedly. We see if necessary only we'll check it, right? In case if we want to get something like there are two solutions, two angles, we convert this to sec squared, then sec squared theta 1 plus tan squared. Otherwise don't jump and put that way. We'll see if necessary we'll do it later. Okay, we'll solve this one. So it will become 2 2h, yeah, minus, doesn't matter, h is so, okay, 1 minute. So h is going to be minus 2hu tan theta. And this plus, sorry, I made a mistake, plus downwards, that should be plus, right? Okay, plus 4 g h squared. So 4 means here this is going to be get cancelled, half here, that I'll put as 2gh squared, here half, here 4, so that will get cancelled, that 4 comes from here, t squared. So 2gh squared over u squared cos squared theta. We'll keep like this. So we can divide the whole equation by h. If I divide it, it's going to be 1 equal minus 2u tan theta plus again I can divide by 2 the whole equation. This u will get cancelled, sorry, the u and u will get cancelled, so that's going to be h equal to h tan theta, 2h tan theta, yeah, 2h tan theta plus 2gh squared over u squared cos squared theta. So it's going to be all the whole equation I can divide by h. So 1 equal minus 2 tan theta plus 2gh over u squared cos squared theta. We'll see, we might use this later. Careful, don't make careless mistakes. I made it. But anyway, so here u and u get cancelled. 2h tan theta, 2gh over u squared cos squared. We'll see, because they are given this data in the question. I used it. We might need it later. We'll keep it like this. We'll see. Right now, the angle we have to find it, tan beta, is it? So for that, VH we know that. So the horizontal component of velocity we know that. That is same as the initial velocity, because horizontally no acceleration. So VH, the final velocity VH is going to be initial velocity u cos theta. Okay, make it as first equation. I need to find the VV. So downwards we use V equal u plus AT. So that means VV. Because I am finding VH and VV, because tan beta equal VV over VH. You have to get that, no other way, right? There's nothing else to do, right? VV equal u initial velocity, I am using downward, so minus u sin theta minus u sin theta plus g downward, so plus g instead of t, 2h over u cos theta. h over u cos theta. Okay, I'll raise this part. So anyway, before that, tan beta I need to find it. Tan beta VV over VH. VV means minus u sin theta plus 2gh over cos theta over, that is what I wrote is VV, minus u sin theta plus 2gh over u cos theta divided by VH. VH is u cos theta. Right? So because we need to find the tan beta, isn't it? Right, we'll continue that. So if I continue that, it will become tan beta equal separately divide u sin theta over u cos theta. If I divide this over this, sin over cos tan, u and u will get cancelled. So minus tan theta plus 2gh over u squared cos squared. So when I divide this by this one, I'll get 2gh over u squared cos squared theta plus 2gh over u squared cos squared theta. I'm getting it, right? Okay. What to do? Now We go that. We got this one here. I told that we might use this because they are given this information. From this one, 2gh over u squared cos square theta is there. No? 2gh over u squared cos square theta we have. So that is going to be 1 plus 2 tan theta. So from this star, this equation, 2gh over u squared cos square theta is equal to 1 plus 2 tan theta. So substitute that. Minus tan theta plus 1 plus 2 tan theta. So it's going to be 2 tan theta minus tan theta 1. So it's going to be tan theta 1 plus tan theta. As the question is, they also show that tan beta equal 1 plus tan theta or tan theta plus 1, whatever it is. We got the answer. Okay, so like that, don't think if I plan before what should I do, I won't get the answer. Just according to the given information, do it, and by using the equation what we got, try to solve and get the answer what they asked to show. Okay. Okay, second part, they also get an expression for the flight time or the time period, capital T equal something to h over g, something like that. So we'll try to find it. So the total time we can get it from here again, second part. Horizontally, if I use s equal ut plus half a t squared, 2h equal u cos theta times capital T they are using for the total time plus 0. Is it no acceleration horizontally? So t is going to be 2h over u cos theta. But that's not the answer. They also show that something in a different format, that is 2h over g 1 plus 2 tan theta. So we have to get that format, is it, according to the given equation, because only thing u is not given in the question. So I have to eliminate the u. Okay, so from here, from this one, the equation star, you can see that u cos theta here, u squared cos square theta. So I think I can get u squared. I have to eliminate, I told u, but including the cos square theta, I can get it. So from that, I can write from the star, the equation star, 2gh over u squared cos square theta equal 1 plus 2 tan theta. So I want to get the u cos theta, because if I substitute here, I might get the equation answer. So we'll try that. So I put that here, so I can raise this part now. Okay, so u squared cos square theta, from here u squared cos square theta equal 2gh over 1 plus 2 tan theta. So u cos theta equal 2gh over 1 plus 2 tan theta square root. I can put it as to the power half. So the flight time t is equal to 2h over u cos theta. So 2h over u cos theta, that is 2gh over 1 plus 2 tan theta to the power half. Anyway, 1 plus 2 tan theta will go up. So this, if I put it in square root, I can write 4h squared. 4h squared over 2gh. 4h squared over 2gh. This one will go up. So that is 1 plus 2 tan theta. All in square root. Correct? No? There's nothing wrong. Yeah, so that's going to be 2h will get cancelled. So it's going to be 2h over g 1 plus 2 tan theta to the power of half. I think that's the answer they asked to show. Yeah, 2h over g 1 plus 2 tan theta to the half. Yes, we got the answer. Okay, question number 6. A particle is projected from point O on a horizontal ground at an angle of elevation alpha to the ground. The range of this projectile motion is r. So the range is given. You know the range is equal to 2u squared over g sine alpha cos alpha, or u squared over g sine 2 alpha. We know that how to derive it. The range is r. During its motion, it passes through a point which has horizontal and vertical displacement of x and y respectively, from O respectively. Yeah. So the horizontal displacement is x, vertical displacement is y. It's passing through a point, right? Show that. This one we had to show in the first part. Second part, during its motion, it passes through 2 points at the same height of h above the ground. So, you know, in a projectile motion, if the particle or projectile passes through the same height, means they should be on either side of the highest point, is it? Symmetrical path, so it should be on the either side of the center part, or either side of the highest point. The horizontal distance between the 2 points is 2a. Show that. This one, r is the range, r into this one, we have to show that. Okay, so nothing new, the same principle related to projectile motion, we are going to use it. Only thing, mathematics comes there. We have to solve according to the given question. Given we have to get this format, so we have to rearrange, and you know we have to use a little bit of mathematics, either trigonometry or quadratic equation. We have to use it. That's all. Okay, so to get expression for the range, most of the books they have, when we consider the whole motion, vertically upwards is equal to ut plus half at squared. When we consider the whole motion, s will be 0 because the particle will come back to the same level. U sine alpha t plus half minus g t squared. So from the t equal 2u sine alpha over g. Okay, so you can divide the whole equation by t first. So t square will become t. So t equal to u sine alpha g. So when you consider horizontal displacement, is equal to ut plus half at square. The range r equal u cos alpha into, instead of t you can put 2u sine alpha over g. So it's going to be, r is going to be 2u squared over g sine alpha cos alpha. So we might use this because mostly we will use the u squared because u is not given in the question. So I included that. Even none of the answers, even the answer does not have 2. Okay, so most probably I'll use the u squared later. We'll see. Now when you consider the point here, for the point they are saying it passes through a point which has a horizontal and vertical displacements x and y. So for the point when I consider, horizontally, s equal ut plus half at squared. If I consider x equal u cos alpha times t plus 0, no acceleration in horizontal direction. So t will be x over u cos alpha. When you consider vertical displacement for the point, s equal ut plus half at squared I am going to use. So y equal u sine alpha into, instead of time I can substitute x over u cos alpha plus half into minus g t square. So same thing we are doing again x squared over u squared cos squared alpha. Okay, so it's going to be y is equal to u and u will get cancelled, x tan alpha, u and u get cancelled, x tan alpha. So here minus gx squared over 2u squared cos squared alpha. So 2 cos squared alpha times, instead of u squared, we can substitute from this. If I make u squared subject, u squared is going to be rg over u squared equal rg over 2 sin alpha cos alpha. So I'm going to substitute that one. So rg over 2 sin alpha cos alpha, is it? So cos squared alpha, here cos alpha get cancelled, 2 will get cancelled, sin alpha will go to the numerator, it will become sin alpha over this cos alpha, this cos squared, so the remaining part is cos, sin will go up, cos sin or cos tan, g and g will get cancelled. So we are going to get x tan alpha minus g and g will get cancelled. X square will remain, 2 and 2 will get cancelled, so r will remain, so it's going to be sin goes up, so x squared tan alpha over r. I'm right. So that's the answer, you got it. Take the x and x tan alpha out of the equation. So I'll continue here, I'll trace this part. Okay, so it's going to be y equal x tan alpha minus x squared tan alpha over r. Okay, so yeah, we are getting that format, is it? So take the x tan alpha out of this equation. X, they are taking that x, I take it out. Tan alpha, they are taking that side. So if I take x here, it will become 1 minus, yes, 1 minus x squared, so x over r tan alpha. That's the answer they asked to show them. We got the answer here. Okay, second part, I am going to use the first results, in the first part. So second part, I'll continue this. Y is equal to x tan alpha minus x squared over r tan alpha. That means I am going to rewrite it and show you. That means this equation shows that for a given speed at given angle alpha. So it's actually a quadratic equation in x squared. So this I can rearrange this as this one, tan alpha over rx squared minus tan alpha into x plus y equals 0. Right, that means here in this question, for the same height h, there are two different walls or whatever it is. So that means for a given initial speed u, for the given alpha, there are two different x such that the same height. So x has two solution, two real value, two roots should be there, x1, x2. x1 indicates the distance of the first wall, x1, and the x2 indicates the distance of the second wall from O. x1, x2 are the roots of this quadratic equation in terms of x. X are the distance, horizontal distance of the first wall and the second wall from the initial point O. Okay, so if it has two solutions or two roots, x1 and x2, it's a quadratic equation. So y is the height for the same height, y is h. Y is h. So I can rewrite this tan alpha over r x squared minus tan alpha x plus h. H is the height. For the same height h, there are two solutions, two roots for x. X is the horizontal displacement. That's the idea. So if I say the roots are x1, x2, I already showed that on the diagram. You know alpha plus beta minus b over a, alpha beta c over a for the quadratic equation, the two roots. So x1 plus x2 equal minus b over a. So tan alpha minus tan alpha. So plus tan alpha over r. So x1 plus x2 equal r, first equation. And we know that x1 into x2, x1 times x2, c over a, that is h over tan alpha over r, that is rh over tan alpha, that is x1 into x2. That is second equation. Also we know that x2 minus x1 is 2a. That's given in the question. x2 minus x1 equal 2a. We need all these three because the question, it does not have anything related to x. It relates only, the second part, it relates only r and alpha, r, alpha and a. So I have to use these three equations to get the expression like x2 minus x1 all things squared, that is x squared minus 2x1 plus x2 squared minus 2x1 plus x1 squared. If I put it in terms of x1 plus x2, that will be x1 squared plus 2x1 x2 plus x2 squared. So minus 4x1. So substitute, you will get the answer. x2 minus x1, that is 4a squared. x2 minus x1, 2a. 2a squared is 4a squared. You can see the 4a squared is there in the equation. Yeah. x1 plus x2, h over tan alpha all things squared. So sorry, x1 plus x2, that is r squared. x1 plus x2, r squared, that is x1 plus x2 r, that is r squared. x1 plus x2 squared minus 4x1 x1, 4x1 x1, 4h, 4rh over tan alpha. That I can write cot alpha. Tan alpha, I'll put it later, cot alpha. 1 over tan alpha is cot alpha. Right, okay, so now I got the answer. That's the format. You can see that. I'll continue on the left side. I'll raise this and continue. Okay, so this is 4a squared equal. Take the r into r minus 4h tan alpha, 1 over tan alpha, cot alpha, 4h, yeah, cot alpha. Yeah, that's the question, is it? They put this on the right side, it's okay, whatever it is. So that's the answer, yeah. Okay, so this is the seventh question. A particle is projected from O at a velocity u and at an angle of elevation alpha with horizontal. During its motion, it passes through a point which is at a height of y above O and a horizontal distance x from O. Show that. It's a normal standard theory. All the textbooks, they have that derivation, nothing. Anyway, I'll do it, but it's a normal general theory. It's in the all textbooks. Yeah, okay. Second part, next thing, a ball is projected from point P on horizontal ground such that it just passes over two vertical walls. So they are not the same height, because the question says that the height of the first wall is A and it is at a horizontal distance of B from P. P is the point of projection. From there they project it from point P. Yeah, point P. The second wall is at a horizontal distance of A from P and its height is B. So it's like that. Show that, this expression we had to show. Then we had to show the range of the ball is this much. Okay, right. So these are things we had to show that. Okay, so we'll start working, but this nothing, I'm not doing it because it's all the textbooks have. So I'm not doing the first part, but I'm going to use this expression for the second and third part. Okay, in that question, theta is the angle of elevation. I forgot to write it, but the first expression is A tan theta minus B over B tan theta minus A equal A squared over B squared. They asked me to show that the second part actually. Second part means first part I am not doing it, it's a theory part. So the second part they also show that A tan theta minus B over B tan theta minus A equal A squared over B squared. They also show that where theta is the angle of elevation of the projectile. So I didn't mention that, but anyway, that's the angle of elevation. Right, okay. So in this answer, we are going to use the first part, which is a theory. All the textbooks have that. That shows that y equal x tan alpha. So here the alpha is the angle of elevation. Then general standard equation, but here we are going to replace alpha by theta, right? X tan alpha minus gx squared over 2u squared sec squared theta, sorry, sec squared alpha. Okay. So if I use this equation in this question, it's a theory part, it's a theory, right? So A and B, two different walls, they are at different distance. So A is at a distance B, the height of B, which is at distance A, right? So the first wall, they are saying it, the height of the first wall is A and it's at a distance of B, correct? Now first wall, height A, distance B, right? Okay. So we'll use this equation separately for the two walls. There's nothing to do. We'll use it. For the first wall, if I write it, it will become, y will become A. For the first wall, if I write it, A is equal to, x is B, B tan alpha minus G, x means B, GB squared, G distance is x, GB squared over 2u squared. Here I will use theta, sorry, because angle of elevation is theta, sec squared theta. This is for the first wall. For the second wall, if I write it, this is for the first wall. For the second wall, if I write it, y will become B. So B is equal to, x will become A tan theta minus G A squared over 4u squared sec squared theta. That's the second equation, right? The question is A tan theta minus B. So that means A tan theta minus B is something we know, that the answer does not have sec squared theta, the answer does not have u squared, answer does not have g squared. So we have to eliminate ga squared over 2u squared sec squared theta, gb squared over 2u squared sec squared from the equation. That's all. So we'll a simple equation. So what will we do? We'll multiply the first, here gb squared over 2. This part is the same. This is the same. This is the same. Only gb squared, here ga squared. So we'll multiply the first equation by a squared and the second equation by b squared. Then we'll subtract and we'll see whether we are able to get that expression. Okay, so multiply the first equation by a squared, we will get a cube equal to a squared b tan theta minus g a squared b squared over 2u squared sec squared theta. Let it be equation number 3. Same way, second equation, if I multiply by b squared, I will get b cube. B cube is equal to a b squared tan theta minus g a squared b squared over 2u squared sec squared theta. That is fourth equation. Okay, now you can see that a tan theta minus b, a tan theta minus b means we'll subtract third equation from the fourth equation. Third equation minus fourth equation we'll get a cube minus b cube equal a squared b tan theta minus a b squared tan theta, because this part and this part will get cancelled, because when I subtract a g a squared b squared 2u squared g a squared b squared 2u squared sec squared, so this part will get cancelled. So remaining will be a cube minus b cube equal a squared b tan theta minus ab squared tan theta. Students, what they do, they try to, I show, normally students, they immediately think of factorizing. Nothing wrong, but you won't get the expressions. That's what I told you. When you are answering this type of question, then and there, you must check the answer, whether we are getting the answer, whether we are going on the proper path to get the answer. If you factorize it, there's nothing wrong, but you won't get that format. Say, this one, if you factorize it, something like a minus b a squared plus ab plus b squared, is it? If you factorize a cube minus b, you will get it. So here students normally they take ab tan theta out and they put this one a minus b. And a minus b will get cancelled. Tan theta will get another form. That won't be the format that we want. Here the question says some other format. They are saying to a tan theta minus b over b tan theta minus a. We had to go to that format. So there here nothing wrong. Mathematics is correct. The principle what I used for projectile is correct. But I won't get the expression what the question says. So don't do this. So here don't factorize it. Without factorizing, I want to get that format. Means what can I do? So a cube. So I did, you can see that a tan theta is there. A tan theta means if I subtract this way, a cube minus a squared b tan theta equal, bring it to the right side, b cube minus ab squared tan theta. Something coming, see this format. So here take a squared if I take it, a minus b tan theta equal to, here take b squared, b minus a tan theta. I think I am getting the, so a tan theta minus b, a tan theta, I think, so here b squared, so a tan theta minus b. Okay, it's coming other way, doesn't matter, we'll multiply by negative sign, it won't be a problem. So that means here I'm going to get a squared over b squared equal b minus a tan theta, b minus a tan theta over a minus b tan theta. But the question is other way, a tan theta minus b, so up and down multiply by minus 1. If I multiply by minus 1, I will get a tan theta minus b over b tan theta minus a. So if you consider this and this, that's the question. That's the answer we have to show that. So a tan theta minus b over b tan theta minus a equal a squared over b squared. That's the question. We got the answer. Okay. So see the answer and think what should I do to get that answer. Okay, second part, again that is something related to range, but you can see the answer. We need to show that range is equal to a squared plus ab plus b squared over a plus b. So nothing related to angle, nothing related to initial speed, everything we had to eliminate. Okay, so little bit work, algebra, we'll see that. Okay, second part I'm going to use the same equation, so I'll put second part here. So I want to use the same equations again, and also I want this one, a cube minus b cube, I write it here, a cube minus b cube, a cube minus b cube equal a squared b tan theta minus ab squared tan theta. So okay, I'm going to use it, that's the reason I wrote it, that I put equation 5. So since I use up to 4, I'll put this as equation 5. Because I need this, but anyway I haven't started answering question number 2. Second part I haven't started answering, but I need all these 3 equations to answer the second part. Okay, so we'll continue, I'll raise that part. Okay, so the question is related to range. So there also I can use this general equation, general expression. So when range means the y will be 0 because it's returning to the same position. It's on a horizontal flow. The projectile is happening or projected from a horizontal flow. So if I use this equation for range, if I substitute x equal r, y will be 0 when we consider the range. So there I can say y equals 0 when it returns to the same horizontal level. No vertical displacement, that is y equals 0, x is r. So 0 equal r tan alpha, r is the range, that's the question, we need to show r equals something, right? r tan theta minus gr squared over 2u squared sec squared theta. So from this, if I try to find an expression for r squared, I'll get gr squared sec squared theta over 2u squared equal r tan theta. Yeah, I can divide the whole equation by r, sorry. I can divide the whole equation by r. If I divide the whole equation by r, tan theta equal 0 equal, divide the whole equation by r. So 0 equal tan theta minus gr over 2u squared sec squared theta. So make the r subject. So that is, if you make the r subject, yeah, you know how to make. I'll write it gr over 2u squared sec squared theta equal tan theta. So from this, r equal, if I make the r subject, 2u squared over g into tan theta here over sec squared theta, g sec squared theta. So 2u squared over g sec squared theta into tan theta. Okay, we'll continue. We can, if you want, you can change it tan theta sine over cos, but I don't want to go to that way because I don't want to go, come back again in terms of sine and cos, because we started with this equation. They asked to show this expression because of this format, so I don't want to change this to sine cos format. So g sec squared theta into tan theta, right, that r. But you can see in the answer, when you see the answer, I told you, then and there you have to check the answer. There is nothing related to theta, there's nothing related to tan or cos theta, nothing related to u. So we have to eliminate all these things. Okay, but we can see that 2u squared over g sec squared theta. So sec squared theta over 2u squared, or 2u squared over g sec squared theta over 2u squared. You can see the b squared if you take out, or here if you take the a squared out, g sec squared over 2u squared is there. So I need to find an expression for that part. Then I need to find an expression for tan theta. I think I can get it from here, tan theta how much. Okay, that's what I'm going to do now. Okay, so now when we consider these two, we have to plan like that. This little bit of too much of maths, I know that. But physics, they won't ask this type of question. So these are mechanics. So they check your mathematical skill, yeah, how you are able to solve equations. Okay, so there I am going to multiply first equation because gb squared, ga squared. Okay, so I want to get this format. I had to eliminate this, I had to remove this part. That's it. Then only I can get this format. So if I want to eliminate tan theta, both sides, multiply this by a, first equation by a. If I multiply, I will get a squared equal ab tan theta, minus gab squared over 2u squared sec squared theta. Too much of equations comes, I don't want to number. Yeah, if you want, I can number this as equation 6. Then multiply the second equation by b, you will get b squared equal, again ab tan theta minus g a squared b over 2u squared sec squared theta. So subtract 6 minus 7. A squared minus b squared, a squared minus b squared. That I can write a minus b into a plus b, I can factorize it. I am going to do that anyway. So that is ab tan theta, ab tan theta will get cancelled. So we are subtracting 6 minus 1, so this will become plus g a squared b over 2u squared sec squared theta minus g a b squared over 2u squared sec squared theta. Okay, so what can we do? we need sec square theta over 2u squared or 2u squared over sec square theta, because here I need to replace this to get the r. At the same time, I can take GAB out. So when I take GAB out, here I can factorize it. So if I factorize it, this is A minus B, A plus B, simple format I want to get. So that will be, I can take GAB over 2u squared if I take it. GAB over 2u squared if I take it. Sorry, 2u squared sec square theta. If I take it out, it will become here A minus B. Is it? Check it. GA into A squared B sec square theta or 2u squared minus GAB squared or 2 sec squared. Okay, A minus B will get cancelled. Here A plus B. I need to get 2u squared or sec square theta. 2u squared or sec square theta, I can get it. Simple format. Right. Okay, we'll continue. I'll erase this part. Okay, so A minus B get cancelled. So when it get cancelled, 2u squared here, A plus B will be a 2u squared over G sec square theta. Bring it. So that's going to be 2u squared over G sec square theta. 2u squared over G sec square theta is equal to A minus B get cancelled. It's going to be AB over A plus B. Am I right? AB over A plus B. Right. I can substitute here. Then what should I do? I have to find the tan theta. To find the tan theta, I wrote an equation, I removed it. A cube minus B cube, I wrote it, is it? So that is, I got an equation A cube minus B cube. I wrote that here before raising it. A cube minus B cube equal A squared B tan theta minus AB squared tan theta. So A cube minus B cube, here we will factorize it, easy. Then we can make it simple format, that is A minus B, A squared plus AB plus B squared. Here take AB out, AB tan theta times A minus B. Okay, so A minus B will get cancelled. So I can find the tan theta. Tan theta is going to be A squared plus AB plus B squared over AB. Okay, now I am going to substitute these two formats, that is this one and this one. Here, I'll get the answer. Check it. Right, that's it. Okay, I'll erase that part. Okay, so R equal 2u squared over G sec square theta tan theta. So R is equal to 2u squared over G sec square theta, 2u squared over G sec square theta, AB over A plus B times tan theta. Tan theta A squared plus AB plus B squared over AB. AB will get cancelled. A squared plus AB plus B squared over A plus B. That's a question, is it? Interesting question, because we are getting the range without initial speed, without angle of projection. When we know the height and the distance of two walls, or if we know the 2 points on the path, their distance and the height, 2 different points, we can find the range, we can calculate the range. Something useful, yeah. Okay, I hope you enjoyed these questions. Too much of mathematics, but I don't think this type of questions will come in Edexcel M2, but better to know how to solve, because it checks your mathematical skill, how to handle this type of question. I hope it will be useful. Okay, bye.